Everybody. Myself, I'm Dr. G.T. Bhavani, Head Department of Chemistry. Respected guest, Dr. V.G. Vaidyanathan Sir, Principal Scientist and Head Center Coordinator, CSIR, Center for Leather Research Institute. Respected Secretary, Lalit Kumar O. Jain. Respected Management, respected Principal, Dr. N. Sujata, dear colleagues, dear participants, and my dear students. Good morning to one and all present here. It's give me a great pleasure to welcome you all. A special welcome is also extended to the guest speaker joining us today. We thank to you, sir, willingness to share your knowledge and expertise, and I am confident that everyone will gain something from your presentation, sir. Today's presentation topic is very valuable. It is emerging technology in your day-to-day life. The topic is new mobilizing enzymes on metal organic framework and its leather application. A step towards the sustainable leather processing. Thank you, sir. In conclusion, the seminar will be valuable and informative experience for us, all of us. Let us introduce our chief guest for today's presentation. Dr. Vaidyanathan sir did a PhD in a bio-inorganic chemistry from the University of Madras and moved to University of Minnesota, followed by the University of Rhode Island as a postdoctoral fellow. He is a recipient for prestigious Ramanujan Fellowship from the Department of Science and Technology. He is the principal scientist, academic research coordinator, and head Center for Academic and Research Excellence, CAT. He has published more than 50 research articles. He served as the editorial advisor, board member of American Chemical Society, Chemical Research in Toxicology, CRT Journal, also guest editor for the special issues in a CRT. He has supervised 20 MSc projects. Currently, he is mentoring for 4 PhD students. He has received more than rupees 2.5 crores as research grants from the various funding agencies such as DFT, SCRB, CSIR, and National Technology Textile Missions. Thank you, sir. I hand it over the session to our chief guest, Dr. Vaidyanathan, sir. Thank you, sir. Please proceed, sir.
Thank you for a nice introduction. Can you hear me?
Yes, sir. Yes, audible, sir. Thank you, sir. Please proceed, sir.
Today, what I am going to talk about, very important topic, which is like one of the initiatives which our institute has started, and we are working on the mission also. So in this work, what we are talking about, immobilizing enzyme on a metal organic framework for leather application. This is actually a process where we can actually reduce the pollution, because today if you look at it in most of the leather industries where it is located, locations, we can see a lot of pollution and a lot of environmental concerns are going on. So to address this today, I am going to talk about this very important topic. Here we initiated our research work in this area like a couple of years back, and we are getting very nice results, and we are further proceeding. And one of research work we are just sharing here for the purpose of benefiting the students basically. So what is actually leather processing? Like always, we used to have the what do you call that? Always we used to have leather bags, and leather jacket and everything we are wearing. But it involves multiple steps from the pre-tanning to post-tanning, more than 14 steps. You need to work on that one. If you look at it pre-tanning, because whenever we are the leather industry always people talk about you are killing the animals, but we are not killing the animals. whatever the meat generated after that, the leftover is the hides and skin, because people are not eating the skins, they are just eating the flesh or the meat. But the thing is, whatever the leftover, the skin, that we are taking it from the shops, and we are doing all the processes, and then we are making it as a product. If you look at it in the pre-tanning, we are procuring the raw hides and skins from the companies or the shops. Then we soak it in bath, and annealing and lining process we are doing it, and we are removing the flesh from the skin, because we can't use the flesh during the processing. So we remove the flesh, and then what we do is we always use the delining process, and we baiting process, pickling process, and chrome tanning. This is the pre-tanning process up to the chrome tanning. That is a chromium liquor we use, chromium salt we use for the tanning. Then only your skin, the skin which we procure from the shops, that will be very stable. Before this step, that is up to 7th step, always there is a what you call a putrefaction of the skin happens. So we have to do all these processes up to the chrome tanning. Once the chrome tanning happens, then the putrefaction stops there. The thing is, it will be stabilized by the various chemicals. The skin doesn't undergo any what you call the putrefaction or the damages or the spoil. Before this step, you will be seeing a lot of putrefaction process. After the pre-tanning, after the chrome tanning, what we will be getting is the wet blue leather. Because whenever we add the chromium salt, the leather becomes like a bluish in color. That wet blue leather, we take it and we do all the shaving or splitting. The reason for is there will be some hair follicles will be there, that has to be completely the hairs has to be removed, so that you will be getting a very nice smooth. And we will be doing it whenever this process, you will be seeing a lot of water will be there. There will be kind of some steps. We will be increasing the pH to remove the hair follicles and other stuff. Then we will remove, bring back the pH to 6.5 instead of from the alkali position to the pH 4.5 to 6.5 region. Then we do the neutralization process. Then what we do is we do the retanning, dyeing, and facial care. That means this is the step where you will be adding the different colors. That is where the leather bags are, materials, jackets, everything, wallets, everything, whatever you are making. Here in this step, we will be adding all the stabilizers, colors and everything we will be adding. So this looks like a very simple process, like 14 steps. It takes a pretty good time. But the more important thing is each step we will be releasing a lot of environmental pollutants. Okay, I will be sharing some of those in the next slide. If you look at it, what is actually? So if you look at it each step, that is like a tanning process, soaking, what are the things happening? There you will be seeing organic waste, then H2S gas is producing, ammonia will be producing in the soaking, annealing, baiting, and pickling process. In the tanning process, your biological oxygen demand, COD, chemical oxygen demand, chromium salts, zinc, and you will be using. So these are all the salts. What happens is it is creating a lot of nuisance to the environment. So we want to get rid of the salts. So today the scenario is if you look at the market, if you go to some trade center like a trade fairs or leather trade fairs, you will be seeing metal-free tanning materials, metal-free. The reason is metal is actually a kind of now allergic to the industries, but still we can't get rid of completely the metals also. And fat liquoring, there you will be using a different dyes, fat, a lot of things, and solvents, formaldehyde. The same thing dyes and fats. If you look at it, a lot of bans the rich chemicals like European Union, SATRA, and every environmental agency. What they do is they have a list of banned chemicals that should not be used in the leather kind of thing. So these are all the things happening. What is what can we do? Can we have something which can be biologically relevant, as well as it doesn't impose a lot of pollution to the environment? This is our goal. So we started our work. So this is our alternative. Can we use enzymes to reduce the chemical waste? Instead of sodium sulfide, because that is the sodium sulfide is like, very harsh chemical that will be used in the annealing process. What happens is when it is mixed with the acid, the sodium sulfate will release the hydrogen sulfide gas, which is highly toxic to the environment. Like even we can't stay there in the chemistry lab itself whenever the H2S gas is passed or something like that. So it is a highly toxic kind of thing. So can we have the replacement instead of using the chemical? Can we have a enzyme for that one? But the problem here is the enzyme is like you don't have the control over that one. What happens? It will be advantage of enzymes in leather industries. If you look at it, it will reduce significant of chemicals, and leather waste can be easily hydrolyzed by the enzyme. What is the disadvantage? You can't control the enzyme activity over the skin. What it will do? It will eat away all the important material over the skin, and you will see a lot of patches on the skin. You won't get a what you call a proper uniform surface of the skin, like a surface on the leather. So we need to control the activity as well as it has to serve the purpose of annealing also. That is where what we have started is enzymatic immobilization on the metal organic framework. So what all the things are available so far in the literature? If you look at it, there are different types of methodologies are available. Solid support for the enzyme immobilization. If you look at it, so if you look at it, sorry, do we have pointer? So here, if you look at it, solid support for enzyme immobilization, we can use the alumina, activated carbon, nanoparticles, zeolites, mesoporous silica, metal organic framework. And what are the immobilization pattern? If you look at it, adsorption, covalent binding, cross-linking, entrampment, encapsulation. The thing is here, if you look at it, alumina or the activated carbon or the nanoparticle, people have used the copper nanoparticle, iron nanoparticle, and they immobilize the enzymes over that one, and they did the leather processing and other stuff. What happens is during this methodology, it is important. Iron, if you use iron nanoparticle for the immobilization of enzyme, iron impart a brown color over the skin. It is undesirable because if I want like a white color leather or something like a different color, I can't use the brown color leather because I can't do the processing over that one. I can't decolor that one also. So that is why the nanoparticle. Second thing is if you are using copper or iron, it is highly toxic because when it is going, you can't remove the particles from the during the process. So what it will be leading to the what you call the drainage, and it will end up in the seawater and pollution. So we have to use like something can be like a reusable kind of thing. So why we are using the metal organic framework is it has a different metal centers act as a cofactor for the enzyme, and it can be covalently modified process. We can do the modifications based on the ligand or the organic counterpart how we are using it, and the particles are in submicron levels. That means this metal organic framework can get into the hair follicles. That is where you will have your the air is present. It will go there and it will do the digestion it will with the enzyme, in the presence of enzyme, it will do it will take there and it will do the digestion, and once you wash it with water, it can be recycled kind of thing. And the second thing is we can always change the metal center. So this is one of the advantage, and easy recovery and the reusability. So what kind of material we can use it? That also here we can tune the metal center, we can tune the organic ligand. So in that way, we can use the metal organic framework easily. So our goal is like a metal organic framework as a solid stopper for the sustainable leather processing. This is our objective. And so what is actually here what we did is we took zinc salt. Why we are why don't we take any other metal? Zinc is like a very important metal for the biologically relevant also. And we took the two amino what you call terephthalic acid as a organic moiety, and we formed the organic framework where, and what we did is we used the glutaraldehyde as a cross linker. Glutaraldehyde, what it will do is it will has a, since it has a di carboxyldehyde, that is like a di aldehyde group, what it does, one end it will attack the NH2 group of the terephthalic acid, amino terephthalic acid, and the other side it will can be linked with the enzyme. So protease immobilized zinc MOF will be like this. And what we did is we have to, before going for the studies, any biological studies, we have to characterize the material, how it is good, what kind of what kind of pattern it is, whether the immobilization takes place, everything we have to monitor. So what happens is, what we did is we prepared the zinc MOF, and the zinc MOF, if you do the powder XRD, because here we have to use different techniques to understand the what you call the coating of the enzyme, the immobilization of the enzyme taking place on the MOF. So what we did was we did the powder XRD. When we did the powder XRD, what happens is the zinc MOF gives you a very nice crystalline pattern. That means what is, how will you differentiate the crystalline in the amorphous in the powder XRD? So whenever you have a crystalline pattern, you will see a very sharp peak on like a 10.9, 19.5, 24.5, 26.2, 32 points, these are all different angle. It will be like a crystalline nature. But when you coat the enzyme over the zinc MOF, what happens is it has very minor crystalline pattern, but mostly it is like a amorphous. That means you won't see any sharp peak, but you will see a kind of a what you call some like a shoulder kind of thing. Once we did this one, then we did the FTIR also, IR spectroscopy, where you will see the changes happening on the functional group. So whatever we are seeing the zinc MOF here, you can see the NH group, the amino from the amino terephthalic acid NH group is there. That is now after conjugation, it becomes like more broadened one, and you can see all the CN binding and CO of the glutaraldehyde, glutaraldehyde, zinc glutaraldehyde, that becomes, that is absent in the once the enzyme is coating over the surface. Then what we did is how the what is the particle size of the material, because we are talking about the submicron level. That means the size of the pores are very, very tiny, so it should be kind of a our material, like metal organic framework, should be very tiny compared to the follicle, so that it can go inside on the air surface and it will remove the digestion part. So what we did was in the zinc MOF, if you look at it, it is like a what you call light scattering experiment. What we saw is like a 165 nanometer, the size of the particle. This is a kind of a distributed size. Then what we did was zinc MOF with after the enzyme, what happens is there is a kind of the size of material becomes little bit after coating, the size of the material becomes increased 460 nanometer. After confirming this, then we did the scanning electron microscope to see the surface, how the surface looks like. What we see is you can see kind of what you call rhomboid shape, kind of shapes zinc MOF. Once you coat the surface, you see very almost similar kind of thing. Here we can't differentiate, but what we saw in the from the from the transmission electron microscope, you will see the coating of the enzyme that will give you a little bit darkish color. If you look at it, this is the zinc MOF, and enzyme, if you look at it, you can see more of the coating here. The surface is more of thing, dark colors. Once we did it, then we did the X-ray XPS studies, where you will see what kind of linkages are happening. So we did for for the zinc MOF and the zinc coated the zinc enzyme coated on the zinc surface. So here you can see the zinc different electron beam patterns here for the zinc. And for the zinc MOF glutaraldehyde and the zinc MOF enzyme. Here you can see different patterns of how the energy levels were shifted from the unmodified to the modified surface. So here you can see a zinc MOF N1 is around 401 negative 401 electron volt for the NS shift from 399.5 electron volt. glutarate binding, and MOF, once the enzyme is coated, oxygen suffers binding energy. If you look at it, it is like, from 532 electron volt, it moves to the negative 533.4 electron volt. Then we have to look at it like, once we prepare anything like, for the applications, leather applications, we have to look at it like, whether this material can be used at a different temperatures. Because our, since being CLRI is one of the renowned leather institute, we have a lot of research, other research centers also across the India. This is a pan-India program. So what happens is like, some people in the Ladakh places, they want to do, suppose if they want to do the processing, if they want to use my product or our product here, so we have to look at it whether this can be serve the purpose of the hannaring, like that. Because this study is more of the hannaring process. We are not looking at any other process, but we are looking at the hannaring process. For that hannaring process, we are using the enzyme, hannaring enzyme, proteases we are using. So whether how the temperature is impacting the activity of the enzyme, and what kind of pH, because we are trying with a different pH, because our leather processing, if you look at it, we do it from 3.54 to 7.5, 8.5 range. We are like, from acidic to alkaline pH. When we are covering, we should know like, how the pH impacting the enzymatic activity also we have to look at it. And when we coat the enzyme, whether it will be leaching out or not. Because whenever our processing, we want to reuse this material. That means whenever we are going for the recycling, whether there is any problem we face, because the compound is not getting destabilized, or it's getting out of the system, or the enzyme is moved, there is a breakage in the enzyme and metal organic framework. So how can we do this process? So what we did is we did the pH and temperature dependent studies of zinc MOF enzyme, and we looked at it how it is like that. So what we did is we tried with the protease activity with a different pH level, and what we found was the pH 7.5 is pretty good, and the temperature, if you look at it, 37 degrees is pretty much good. Even at 15 degrees, it is kind of going good kind of thing. So at pH 7.5, we can use it at even 15 degrees to for 60 degrees we can use it. Because if I want to use it in Rajasthan during the summer, the temperature will be around 50 degrees. So how the pH is how the temperature impacts the enzyme activity. What we saw is it is pretty much not getting impacted by the temperature from 15 degrees to 60 degrees. But pH, if you look at it, pH, yes, it has an impact. So what we did is we kept the temperature 37 degrees, whatever the temperature what we have in Chennai. Then we took the pH 7.5 and the temperature is 37 degrees. And what we did is we did just to take the immobilize the enzyme on the metal organic framework. And what we did is whatever we do it in the drum, because most of the time what we use is drum for the leather processing. So what we did is we mimic the system similar way, vortexing kind of thing. We just shake it for some 3 hours, 4 hours kind of thing. Then we looked at it whether the enzyme is leaching out during the cycle. What we found is, yes, there is a decrease in the activity, and how much protease is concentration of protease from each cycle, how much it is leaching out. Up to 4 cycles, there was not that much leaching is happening. After 4th cycle, yes, there is a lot of protease is leaching out after the 4th cycle. So what we did was we stick with the process is up to 4 cycles only. Then what we did is we have started in the application itself. What we did is we took a small portion of the skin, and what we did is we added the immobilized the enzyme, the protease, immobilized the protease and zinc MOF in coated on the. What we did is we actually coated on the surface of the skin, that is having the hairs. Then what we did is we looked at it then the hannaring process, we look at it whether the hannaring process is taking place. What we did is we used to rub the surface so that the air will come out. So once it is, then it is completely washed, and we looked at it under the scanning electron microscope. and we want to look at it whether the zinc morph goes inside to the follicles kind of thing in the hair. What we are seeing is like, all the dots, whatever the dots we are seeing, it is actually zinc morph is getting penetrated into the skin. Then it is really for us, it's a happy news. The reason is the zinc morph goes into the skin, like, it is a hack, like, doing this, it's, activity, like activity process to remove the hair, to remove the hair from the skin. Then what we did is we actually did the control protease, because control protease, because that is our positive control. So what we did is we took the skin and we added the 5% of control protease, and we looked at the surface, and it is completely removed. And if you look at it, the bottom portion of this one, zinc morph enzyme 2.5%, it is not doing that much. So what we did is we have taken 5% loading of enzyme on the zinc morph, that is the immobilized enzyme. Then we treated with the skin at a cycle 1. And what we did is in the cycle 2, we added extra 2.5%. The reason is each step we are losing some kind of morph during the process, because since it is having a lot of air, it goes inside. When we wash also, it is not moving out kind of thing. So there is a loss. So for each cycle, we add 2.5%, but we recycle the first addition of the zinc morph. So each cycle, what we are seeing is up to cycle 4, what we are seeing is we could see the complete removal of the air from the skin. Then what we did is whether the skin, after adding the zinc morph the cycle, whether the follicles are the what you call it, whether the zinc morph is doing any damage to the as the wherever the follicles, where the surface is smooth or not. So for that, we did the scanning electron microscope. We want to confirm the integrity of the skin is maintained, whether it is a control or the what you call the A is the control, and the other systems are B and C are the cycle 1 and the cycle 4. How the enzyme is behaving, and if you look at it, whether it is a control protease or the zinc morph plus enzyme, immobilized enzyme on zinc morph on the skin, it's everything is maintained very well. Then what we did is we again went for the bigger piece of this is something like a 5 centimeter to 5 centimeter. Then what we did is we cut the big skin, that is like a one what you call the goat skin we took, because the reason here, I want to stress here also, different skin patterns. If you take the cow, the hair will be little bit spreadable kind of thing. But if you take the goat, if you look at the goat skin, it will be too tight. The hair will be very tight, too much of hair will be there compared to the cow skin. So what we did, cow eyes. So here what we did is we took the goat and we took like a whole goat skin, that is like something like a 1 kg kind of thing. We took it and cut it into something like a 250 milligrams scale, like a bigger piece. Then we treated the same way what we did it for the 5 by 5 kind of centimeter kind of thing. So what we saw is in the bigger scale also, this zinc morph doing the work. That is like a happy news for us, because it is doing this is the first time in the leather industry itself, leather applications itself, morph has been used. So far, so the question arises what is the feasibility, whether the industry can take up, what will be the cost, because sodium sulfate costs you very less compared to the zinc morph based this one. But enzyme, it's people are reluctant to use it. The industry, the reason is it is kind of what you call, it is pretty expensive and it is uncontrollable. So now we want to address these two things in one shot. We're using the zinc morph and the enzyme, and the activity can be maintained so that we can do a multiple cycles also. That way the cost can be cut down. And second thing is the pollution load to the environment we can be cut down. So that is the purpose what we saw here. And the next thing is we want to look at it how the histological stain, like a dehydrated skin, enzyme treated and zinc morph enzyme treated, everything is perfectly going good. There was not any problem on the skin. So overall, then whenever people do the Hanaring process, they want to go up to the chrome tanning or the tanning and see how this enzymatic process gives a better stability, mechanical strength or tensile strength, grain crack strength, thickness, softness, everything, because there will be always some changes will happen when you are using the sodium sulfide based annealing process or the enzymatic annealing process. So we want to make sure it is everything is compatible and everything is matching with the what is available out there in the commercially. So we looked at it, the softness, we looked at thickness, grain crack strength, tear strength, tensile strength, elongation at break. And if you look at it in all the cycles, up to 4 cycles, it is giving you a very good, nice results. So this is the conclusion. I just want to look at it, give it to you. We prepared the zinc moss, and it is with the enzyme immobilized, because here it is not the just the adsorption process, because adsorption process will give you lead to the leaching of the enzyme. So here what we did is we used the glutaraldehyde as a cross linker, and we immobilize the enzyme over the zinc moss, and we characterize using powder XRD, FTIR analysis, and the EDAX analysis, that is the energy dispositive system. Then we looked at it like FSM analysis also, how the grain pattern of the skin looks like, and we found that zinc moss is a suitable product, a solid support. Now what we are doing is can we use different system in one shot at higher pH? We don't want to go back pH variations, because in the initial process of annealing, we will be changing the pH from 4.5 to 9.5 kind of thing. Instead of going for multiple going to higher alkaline pH to coming back to pH 6.5 kind of thing, can we have a highly stable metal organic framework at higher pH which can withstand the higher pH? Then can we use it that material for our enzymatic process? That is what we are currently working on. So before closing down this session, I just want to share what is going on in CLRI also, because a lot of people think about CLRI is meant for the leather research only. No, is it? It is part of the leather research, but we do also. Sorry, I think that slide is missing. We do also one second. We do also using doing what you call the different research, from basic research from inorganic chemistry, organic chemistry, polymer chemistry, then biochemistry, AI and ML. Okay, so if you want to I always invite all the college students to come and visit our institute. Whenever you have time, you can contact me. My email ID is available in my presentation first slide itself. You can always email me, and you can come and visit our institute. Thank you for the organizers. Thank you, ma'am.
Thank you, sir. Sir, please, sir. Any questions are there? Actually, sir, thank you, sir.
Yes, ma'am.
Sir, someone asking questions, sir.
They can actually put it in the chat box also, so that I can see and I can address the question also. If suppose
Yes, sir.
That also people can use the
okay. Yes, sir. We are conducting conference, sir. That's why, yes, sir. Sir, any exams, competitive examinations are there? Someone is asking, sir.
So
to enter the.
yes. MSc, they have after completing the MSc, they have the JRF NET exam is there. CSIR NET exam is there. Then graduate aptitude test, that is GATE exam is there. Apart from that, suppose if they are in biochemistry or a biological field, they have the BET exam is there, conducted by the DBT India. The Department of Biotechnology, they have the BET exam. Then like a pharma companies, pharma, suppose if pharmaceutical means, they have the GPAT, how the GATE exam is that, they have a GPAT also. So apart from that, for the ladies, they have a lot of schemes also. They want to suppose people after completing their masters, they get into family way, then they can't continue the PhD kind of thing. They have a different programs, DSP is offering PhD wise program is there. Right now, they recently, a lot of female students, they are getting into PhD wise program also. And for the professors, they have a different programs like a TAR and other stuff is there.
After completion of examinations, directly
Huh?
if completed a JAM examination, then it is possible to enter the your labs, IIT or your lab.
Yes, the thing is they have to, like, if you replace, someone is asking if we have another, just 1 minute, ma'am, someone asking, if you replace zinc metal, definitely we are working on, apart from zinc metal, one of, I think, Rider Kuti Papa, something like that. Okay. So that person asked if you replace zinc metal. Yes, definitely we can replace any metal ion in the zinc MOF, in the metal organic framework. That is one advantage, because sometimes applications also varies. So right now we are working on the zirconium and the titanium system, because zirconium gives you, very stable, highly stable in the alkaline pH. So that MOF we are working on, almost we got a very nice results on that one. So we are cutting down even couple of pH variations also in this case. If we have any other analysis method, definitely we have lot of methods. Like a year, for each system we need to do for the, what you call that, depending on the system what we are looking at. We are doing FTIR, then we are using the UV for the pH, protease stability or the protease leaching, enzyme leaching. So UV you will be using, FTIR you will be using, SEM you will be using, TEM, powder XRD, DLS. Apart from that, you can use the DSC and TGA, that is differential scanning calorimetry and thermogravimetric analysis, how the system is so stable kind of thing, that we can look at it through the DSC and the TGA kind of thing. Any other questions? So the thing is, for that, I will continue with your question, ma'am. For the MSc, they have to write, they have to go for, after completion of MSc only, they can appear for this exam. But in the third semester of MSc, they can start writing. Every December, there will be a call. December and July, they have the exams, NET exams. So July and December, they can write. So yearly twice. GATE exam comes generally in February. I think the advertisement is over last week, a couple of weeks back. And the upcoming December, they can write the CSIR NET exam, because the results were out last couple of weeks back only. So yet to a call for yet to application call is still pending. Any other questions?
Yes, sir. Yes, sir. One of them asking, my motivation is scientist, become a scientist. What can I do, sir?
So what is can that person always they can call me, or my number I can tell you if you want. I can share my number. You can WhatsApp me also. I will immediately respond to you also.
Yes, sir.
So
Thank you, sir.
If you want, you can note it down: 9677.
I need, sir.
Yeah, 9677104826. You can always WhatsApp me. I will be 24/7. I am in the WhatsApp. So your response will be reached very soon also. If you respond, say hi now, I will be saying hi now also. So you can be you always come to our institute also. You can meet me in person also. I will guide you what all the things can be done. Okay. In person, I will right now I'm just the academic research coordinator also. So we actually give them all the counseling also. I do personally, a lot of students comes, they what kind of things they can do, that I will be sharing also. Always you can ping me in WhatsApp. Yeah, you can ping me in WhatsApp, and you can reach me in the lab itself. Always come and visit CLRI. It is one of the finest national lab, and we are having a what you call a huge facility also. Like all the instrument facilities are available. One of the NABL accreditation lab also. We do a lot of finished leather testing also. and a lot of opportunities. Whenever you complete your MSc, always look at CLRI webpage for position openings. It is almost every month we are having some kind of openings for the project associate, and it's a very good stipend also, from 25,000 to varies from 25,000 to 40,000 rupees. Apart from that, for the BAC also sometimes we have the recruitment, for the project assistance there is a recruitment. You can look at it, the advertisement also in CLRI.org, www.clri.org. Look at it.
Yes, sir. Thank you, sir.
Yes, ma'am.
May I hand it over the session to the vote of thanks, sir? Thank you very much, sir.
Thank you, ma'am. Good afternoon to all. I deem it a great honor and privilege to propose the vote of thanks on this memorable occasion. Let me first of all start by giving glory to the Almighty God for making today's session a resounding success. First and foremost, I thank you, a special guest, Dr.V.G.VAIDYANATHAN, for sharing your talent and important words with us. Together, we have provided us invaluable information regarding immobilizing enzyme on metal organic framework for leather application. With a great pleasure, I would want to express my gratitude to your management for providing this opportunity and for agreeing to host this 7 days webinar. My heartfelt thanks to your esteemed principal in charge, Dr. N. Sujata, is the driving force behind the encouragement and strong belief in teamwork. I consequently on into my HOD, Dr. G.P. Bhavani, and the entire team, the participants, and my lovely students to express my gratitude. I thank you, our program manager, PRO, Mr. Balaji sir. Once again, I thank you all for your attention. Thank you. Finally, I am Praveen Kumar V.
Thank you, sir. Thank you very much, sir.
Thank you, sir. Thank you, ma'am.
Okay, sir. Thank you. Yes, sir. Thank you, sir. Thank you. Wind up, sir. Yes, sir. Finish it, sir. Thank you. Thank you, sir.
Thank you, ma'am.